Hi guys, Chris Frazier here at the Discovery Science Place. This is your Science on the Spot, and today we're going to be talking about a pretty incredible material called dry ice. So get ready for a cool Science on the Spot. Unlike some of our usual Science on the Spots, this one would definitely require some parental or teacher supervision because we're going to be dealing with this cool material that you see right over here called dry ice. And even though it may look very similar to the ice that comes out of your freezer, it is definitely not. So get prepared for some cool experiments with dry ice. Hi guys, Chris Frazier here. So we're talking today about dry ice. Dry ice is actually a solid form of carbon dioxide. You can see it bubbling back there behind me. Normally, of course, carbon dioxide is a gas that we see or think of in the air around us as a gas form. Of course, matter can come in a solid, liquid, or gas form, and there is even a fourth state of matter called plasma, but not too commonly seen here on Earth. So let's just stick with solid, liquid, and gas. If we think about regular water, it can easily come in a solid form, the ice that comes out of your freezer. If you let that ice cube sit on a sunny windowsill, it eventually melts into water. And then eventually that water evaporates into water vapor, which goes up into the air. Hard to see. Once it gets up into the air, the particles and molecules are quite small. So that water doesn't change from H2O. It never chemically changes when we change state. All we're doing is adding or subtracting energy from those molecules. So in the ice form, the water molecules have very little energy. They don't vibrate or move much. They tend to stay in one solid piece, one solid place. When you add energy, say from the temperature of the air around you or the sunlight, that water will then melt. That ice cube will melt. You are adding energy to those H2O molecules, and then they take on a different state. And then finally, if you continue to add energy, let's say you put that ice cube in a pan and you stick it on a stove, eventually that's going to evaporate and that water is going to become a gas form. And those molecules are very excited. They have lots of energy. Now, carbon dioxide normally is a gas around us, but if you take carbon dioxide and under an extreme amount of pressure and very low temperature, you can turn it into a solid. So that's what we're going to talk about today, solid carbon dioxide, which is called dry ice. Now, you need to be careful with dry ice because it's definitely not what you find in your freezer at home. You're going to notice I wear glasses. If I didn't have my glasses on, I would be wearing some form of safety goggles. You'll also notice that I'm always going to be wearing gloves. This material is far, far colder than the ice that you find in your freezer at home. That ice is going to be below 32 degrees. That's where the point at which water becomes a solid ice. And maybe it's down to 0 degrees. So let's say the ice in your freezer is at 0 degrees Fahrenheit. Well, the dry ice that we're going to be looking at is well over 100 degrees negative. So well over, I think it's actually 109. So 109 negative degrees. So far, far colder than the ice you find in your freezer, and it can do quite a bit of damage. It can cause frostbite almost immediately. You would never want to handle it with your bare skin. You would never want to do some crazy things that you sometimes see people do on the internet, like put it in your mouth or anything silly like that. It can cause some severe damage. So let's take a look at some cool experiments using dry ice. The very first thing I just want to mention about the dry ice is even though it does look very familiar, it does look like ice or snow that you might find at home or outside on a cold winter day. It's not. It's hard to see in the video, but if you look very carefully, you can kind of see streamers coming off of the dry ice. It looks like little streams of fog. If you look really carefully on the table there, you can see little streams of fog seemingly coming off the dry ice. What that's doing is it's actually what we call sublimating. It's going to go from that solid state directly to a gas. It's never going to become a liquid at this particular temperature and pressure. So when a material goes straight from a solid to a gas, while skipping the liquid step, we have a special name for that, and it's called sublimate. So that's what the dry ice is going to do. If we left it here for a few minutes, say 30 minutes or so, these cubes will be completely gone, and there'll be no evidence that they were ever there because they will have sublimated into the air around us. So the first little experiment we want to do is we simply want to put the dry ice into some water. Now, I've added some coloring to the water. You don't have to do that, but it's a cool experiment. If we add coloring to the water, will that change the color of the gas or change the color of the fog that we see? So I've got red, blue, and green. This water is also a little bit warm. It's a little bit heated because that's going to speed up the sublimation process. So I'm going to drop some of the dry ice in. And as you can see, the color of the water doesn't have any impact on the color of the fog. And if you look closely down at the bottom of the cup, you can see the dry ice sitting down there bubbling away. It's changing from a solid to a gas. It's sublimating very rapidly. The fog that you see is simply the gas, the carbon dioxide gas, trapped in the water and water vapor. So this water vapor is always going to be this gray color. It doesn't matter what color the liquid is. The coloration of the liquid, the dye or the food coloring that you use, does not change state and become this gaseous fog. It stays inside the liquid there. Oftentimes you'll see this, especially around Halloween. Dry ice has been used for a very long time for this special effect. Of course, there's now modern, different methods for getting this same sort of effect, but still you'll see movies and theaters and TV shows that use dry ice, especially around Halloween, to give this very cool effect. There are a wealth of cool little experiments you can do with dry ice. One of them is to put out a fire. So we're going to use this birthday candle as our fire, and sitting underneath the birthday candle is just a little measuring cup filled with dry ice. And if we take off this portion, of course you can see the dry ice down inside there, and what you don't see is all the carbon dioxide gas that has built up inside this little container. So we're going to light this flame. Of course, a flame is going to need heat, it's going to need a fuel, and it's going to need oxygen. And then we're going to pour carbon dioxide, invisible gas, onto that flame. It's going to take away the oxygen, it's going to put out the fire. So we'll get our lighter going, light our birthday candle. I'm actually going to set it down right here on the table. And now I'm going to pour this invisible gas out onto the flame. And you'll see almost instantly the fire goes out, mainly because that carbon dioxide gas is displacing the oxygen, and the flame needs the oxygen to survive. So again, I'm going to pour this invisible gas out and put out the fire. Oftentimes, there's a type of fire extinguisher that actually uses carbon dioxide gas in the same exact way, but it's a cool example to show kids that even though we can't see the gas that is floating around inside here, it's actually there. Just like the air around us, it does exist. These molecules, even though they're too small for the human eye, they're there and they can have an effect on the world around us. The second way to see this invisible gas is to fill a container like we've done here with a couple of chunks of dry ice, and the carbon dioxide gas will build up inside that container, and it basically creates a cushion that this bubble is riding on. So even though that invisible gas, we can't see it with our eyes, it's there and it's present, and it's actually dense enough, denser than the air around it, that it allows this bubble to float on top of that layer. So I'll attempt to blow another bubble on top. That may be hard to do with one hand, but we'll give it a shot. So we have carbon dioxide inside the container. I'll try to blow a couple of bubbles. And notice how the bubbles tend to rest on something. Don't know what they're resting on, but they're inside that container. They're not immediately floating to the bottom. They're resting on a layer of invisible carbon dioxide gas. Oftentimes I get asked if kids can play with the dry ice, and of course that is not a good idea because of the dangerously low cold temperatures. But there is one way that you can get them to kind of play with the fog in a bubble form, and this is what we're going to do. So we've mixed up a soap solution. It looks kind of red because I had a red handkerchief in there, but that's just quite a bit of dish soap and water. And then I just have a container over here. We're going to pour some nice warm water inside that container. And then we're going to add some dry ice so we can create some carbon dioxide gas. So let me grab my glove. The dry ice, I've already cracked it and crumbled it with a hammer. It comes usually in a solid block, but the small pieces actually work better for the experiments that we're doing. So I'll grab a handful right over here to the water. Immediately, of course, it starts to sublimate and looks awesome. And again, it's going to be more difficult with a single hand, but you'll see that I have this contraption that we've made with a funnel on one end and the cup on the other. And I'm going to set the phone down and see if we can record making some bubbles. All right, so what we're going to do is we're going to dip the end that has the funnel into the soap. And I'm simply going to put this end down inside here. And we're going to create some bubbles. These bubbles the kids can't actually touch and hold. They're simply soap bubbles, but they happen to be filled with the fog from the carbon dioxide gas. So this is a good way that you can allow the kids to actually play with the soap bubbles and the carbon dioxide gas without any danger to them, because the gas itself isn't harmful and isn't super cold. A second way to allow kids to have a bit more fun with the dry ice, but still be safe, is to take warm water, put it in a glass bowl like this, something that has a smooth edge, drop some dry ice. Of course, immediately it starts to sublimate. I love the fact that it's denser than air, so it kind of filters down toward the ground. And then you need some soapy water in a handkerchief like this, and we're going to make one giant bubble. So let me set the phone down and we'll take a look. All right, so what we want to do is we want to take our soapy solution, mix that up with our handkerchief, and we're just going to run our handkerchief across the top of the bowl and allow it to form one huge bubble. That bubble will get larger and larger and larger, almost like a giant eyeball. Has some beautiful iridescence on the top, kind of like a prism. Eventually it's going to break. The kids tend to get very excited at this point, waiting for it to break. And what I like to do is just let it grow as large as it can and just let it break on its own. Sometimes you'll get kids inevitably that want to stick a finger in it and pop it, which of course is fine, but it's more fun just to let it go on its own. And if you want to do that again, you can always add some more warm water, more dry ice. Get your soapy handkerchief, run it over the top, make a smooth, thin film of soap, and watch that bubble grow again. Another fun way for the kids to enjoy the dry ice, but not so dangerous because the dry ice stays at the bottom of the bowl. As long as you make sure that the kiddos keep their hands out and away from the bowl, you're good to go. One last quick little experiment to finish. This one does require a few materials. It's helpful if you have like a graduated cylinder or some type of tall, thin item like this. This is our launch pad. And then this is going to be our rocket. You need a film canister, and I know in today's modern age, film canisters are hard to come by. Particularly, you need the kind of film canister that has the lid that snaps inside, not the gray can with the black lid that goes over the top, but the kind that you see here that actually snaps inside. What we're going to do is we're going to add a little bit of warm water to this, or actually I'm going to use just tap water, cold water, because if I do warm water, it happens way too fast. And then we're going to put a bit of dry ice in there. We're going to cap this, and then I'm actually going to drop it inside, upside down, and in just a few seconds, of course, that sublimation is going to take place. That gas pressure is going to build up, and that rocket is going to blast off using our launch tube here. All right, so I've added a little bit of water. I didn't add warm water because if you do warm water, this reaction happens so fast, it's a bit dangerous, and you don't want to do that. So just regular temperature water or cooler water is fine. I'm just going to grab a couple of small nuggets of the dry ice. I don't need much at all. Just that one tiny little nugget is fine. I'm going to drop that in there. Immediately, it's going to start sublimating, making that gas, and I'm going to cap it, and I'm going to drop it inside really quickly. So cap, drop, and now, because I use the cooler water, it'll take at least a couple of seconds for that pressure to build up, but once it does, it goes off pretty violently. So you would want to make sure that the kiddos are well far away from your little tube here, because that pressure builds up violently, and it does take off. It easily hit our ceiling about 8 feet above. It would have gone about 20 feet up in the air had I not had a ceiling. Finally, when we're talking to the kids here at the Discovery Science Place, I always want to give them a spa treatment toward the very end of our dry ice discussion. So this is my container that I have my hot water in, just a coffee urn or something similar. At the end of the day, when we're just about done with all of our experiments, I will go and I will grab a bunch of the last remaining dry ice, and I will chunk it in this container. let it really put forth some nice fog, because that water is nice and warm inside there. And then I will take this and I will pour it over the kids' heads and tell them they're getting a CO2 spa treatment. It's harmless. The fog is actually a bit warm because of the warm water. And I make sure that the water level is down far enough that I couldn't possibly pour that out. I'm simply going to pour the fog out. It looks something like this, and the kids really enjoy it. The kids like to see their hair seemingly on fire with the fog. And they get a big kick out of it. Relatively harmless. Of course, you do want them to not be in the cloud of fog for too long, because it is CO2, but you would have to basically fill the entire room with CO2 before it would be harmful or cause any sort of problem. So just a quick douse on the hair there. The kids love that. We call that our spa treatment, and that's how we end our CO2 and dry ice presentation here at the Discovery Science Place. So the last thing I wanted to say was, a lot of parents ask me, where can I get dry ice here in Tyler? You can actually get it at a couple of different locations. You can find dry ice at some of the local Brookshire stores, at some of the local Walmarts. They usually have a special cooler that is right up front near the checkout stand. They are not supposed to, and generally do not, sell it to anyone under the age of 18 due to the danger. If you're going to get a fair amount of dry ice, like if you're going to do a whole Halloween party or you want to do a lot of experiments, I would go to Tyler Dry Ice Company. They're located on East Irwin. There you can buy whatever amount you want. If you want to buy a single pound, all the way up to 10, 20, 30. If you want to buy 50 pounds, you can buy 50 pounds at Tyler Dry Ice on East Irwin. The cost is relatively cheap for all the fun that you get. It's a little over $1 a pound, maybe $1.10 or so a pound. So it's a lot of fun. Again, not something you would want the kids to play with by themselves. You would definitely want to supervise, but it's a lot of fun. You get to talk about states of matter and energy and all sorts of cool things, and it's a great day. So I want to thank you for joining us for our Science on the Spot. Hope you enjoyed that, and hopefully we will be able to come back to you soon. Come visit us at the Discovery Science Place. We are currently opened, even with our COVID restrictions, Friday, Saturdays, and Sundays. And again, right now, currently, it is late July now. We have our arachnids exhibit. It's a very cool spider exhibit with over 100 living specimens of spiders over in our annex. That's going to be with us until November 15th. So come enjoy. We hope you do. Have a great day. We'll finish by taking a look at some of this cool dry ice. You can hear it bubbling away inside there. Have a great day, guys.